Bismillahirrahmanirrahim. I'm Asim Abbas. This is tutorial number 1. It is about how to model and analyze beam in SAP2000. The main objective of this tutorial is the student will learn how to model and analyze beam subjected to different kind of loadings. Right? For this purpose, I will solve few example of beam in SAP2000. Fine. Before solving example, I will quickly go through the general procedures used to solve particular structure in SAP2000. Fine. Okay, this is a general procedure. This procedure is mainly divided into three different phases: phase 1, phase 2, and phase 3. Phase 1 is also called pre-processing phase, where the different structure properties are defined and assigned. Like in this phase, you will create a new model, then you will define grid system and edit grid system, then define different material properties, then you will define member cross section, then you will define load pattern, load cases, load combination, and also drawing different members, assign joints, and assign load. Coming toward phase 2, it is analysis phase, and it is mainly related to the analysis of structures that is modeled in phase 1, where different load cases are set to run. Fine. And it is actually a bridge between phase 1 and phase 2. Now come towards phase 3. It is called post-processing phase. It is related to the analysis results of model and its designing, where analysis and design reports are developed or generated. This is all about the procedure while working in the SAP 2000. Now come towards solution of different example. This is example number 1. In this example, a continuous beam is subjected to a uniformly distributed load, uniform distributed dead load, and uniform distributed live load. Fine. And the cross section is given by 18 by 30 inches. And the other properties are given here, which is the concrete property. The modulus of elasticity is 3600 ksi, Poisson ratio is 0.2, compressive strength is 4 ksi, and steel yield strength is 60 ksi. And the load combination is 1.2 dead load plus 1.6 live load. Okay, we will solve this example in SAP for the combination of 1.2 dead load plus 1.6 live load to create new model. Okay, how you will create new model? How you will access a new model? You will go to the file. From file, you will click on the new model. Okay, so the new model dialog box will open. Right? Now from here, you will set your unit as per the requirement. Okay, I will keep my unit skip feet. Then you will click on the grid only. Right? And then you will decide, you will define, you will enter the different number of grid lines in X direction, then number of grid line in the Y direction, then number of grid line in the Z direction. Similarly, you will also enter the grid spacing. Fine. Keep in mind this thing. Grid line is required where you want to assign support condition, where you want to apply load, where the cross section is different. Fine. So in our case, in this case, how many grid line we required in this particular direction, which is actually the X direction? We required 3 grid line in the X direction. This is 1, this is 2, and this is 3. Okay, what is the spacing between these the grid lines? These are the 24 feet and 24 feet. Fine. Okay, here we will define 3 grid lines in the X direction. There is no need of any grid line in the Y direction. Keep it 1. and there is also no need of grid line in the z direction. Keep it 1, and the spacing is actually 24. So rest spacing will also be kept 1 feet. Okay. Now the grid lines are developed. The grid lines are not visible in this view, which is the XY plane. So you will switch to the XZ plane where you can see the grid lines. Okay. Now the grid lines are visible, A, B, and C. After defining the grid lines, now you will define the other properties. Okay, first of all, we will define the material properties. Click on the define, then click on the materials. Okay, this window will appear. Then we will add new materials. From this add new material tab, you will click on the add new material. Initially, you will change the name of this material. For example, this is concrete 4 KSI. Fine. Change the material type here to concrete instead of steel. Now here you can also change your units as per your requirement. I will change unit to keep inches. Fine. Okay. This is the weight and mass property. I will keep it the same as it is given here. And I will change the isotropic property data. From here, the elastic modulus is actually 36,000 and Poisson ratio is 0.2, and the specified concrete compressive strength is 4 KSI, right? Click on OK. This material is defined with the name of concrete 4 KSI. Click on OK. Now, next step is to define sectional property. Okay, so click on the define tab, then click on the section property, then click on the frame section. Fine. Now here you can add new property. Click on the add new property tab. Then from the material section, from the frame section property type, you will change it from steel to the concrete. Okay, in our case, the cross section of the beam is rectangular. Okay, so click on the rectangular. So this window will appear. From here you will change the name of your section. It is actually 18 cross 30. Fine. And also change the materials property from here, which is concrete 4 KSI. Right. Now, what is the depth of concrete section? It is actually 30 inches. So 30 the units in feet. So put value in feet. 30 divided by 12. Fine. And the width is 18. So 18 by 12. So the value is converted to the feet. Now from the concrete reinforcement, because this frame section is beam, so change concrete reinforcement from column to beam. Fine. And this is the concrete cover to longitudinal rebar, and which is we keep it 2.5 feet, which is 0.2021 feet. Okay. Okay. Now your frame section is defined. Click on OK. Now next step is to define the load pattern. Click on the define, then click on the load pattern. Actually, in our beam, we have to apply dead load as well as a live load. So you will define two load pattern. What is dead load, which is already by default defined, and we will just define live load. So change load pattern name from here, and then type to load, and then add this property. Fine. Now you will define your load cases. Fine. And dead and live load pattern is already defined, and these load cases is automatically generated over here. But we can develop a combination of load cases. Add on new load case and set, for example, this is load case 1, and you want to do static analysis, and it is a linear as well. Fine. From here I will add dead and live combination. Fine. Click on OK. Now define load combination, then click on the define, then go to the load combination and add new combo. Okay, click on the add new combo, define the name of this combination. For example, its name is 1.2 dead load plus 1.6 live load. Fine. And the combination is dead 1.2, edit, and also live, and its scale factor is 1.6. Okay, click on OK. This combination is defined. Click on OK. Fine. Now we are in position to draw this beam, your element. So how you will draw your element? Actually, it is a frame element, so you will draw this by using a frame element tool. Okay. From draw to menu, you can draw this element. How? Okay, just click on the draw. So this is a draw frame oblique cable. Okay. And below this there is a quick draw frame as well. From here you can just draw your element with single click, but you will use this one, draw frame. Fine. You can also access this draw frame element tool from this side toolbar. Okay, from here you just click on this, so this window will appear. Keep in mind, in this section property you will change the section, which section you want to draw. Okay, we want to draw beam 18 cross 30 inches, so click on this, and there's just then you will draw this element point to point. Click on the first. There is 3 supports at location A. Hinge support is there. At location B and C there is a roller support. Okay, how you will assign these supports? First of all, at location A, you will select this particular point where you want to assign support, then go to assign, then join, then restraints. Okay, this tool will appear. From here you will assign your support. Okay, this is hinge support. Select this hinge support and OK. Fine, this support is created. Next 2 supports are roller support. To select both joint at a time, and then go to the assign, then joint, then restraints, then click on the roller support. Okay, supports are created. Now next step is to assign load. Okay, as per the example, the load is applied uniformly distributed throughout this beam, and the magnitude is 2.2 kip per foot, which is dead load, and 1.6 kip per foot live load. Okay, now we are in position to assign these 2 loads. Fine. For load assignment, select both frame element, then go to the assign, then go to the frame load. Okay, from that frame load, go to the distributed load. So this window will appear. So from here, first of all, you will set your units. So your unit keep in feet, it is okay. Now from load pattern, select the load pattern. Okay, first we will apply 2.2 kip per foot dead load, then we will apply 1.6 kip per foot live load. Okay, it is in the direction of gravity, and it is actually the force. So from here you will apply a uniformly distributed load. What is the magnitude of this dead load? It is 2.2. Click on OK. Once you apply 2.2 dead load, then again select these two and apply or assign live load. Then go to the assign, then go to the frame load, then distributed load. Again from here click, it is 1.6, but keep in mind you will change the load pattern from dead to the live. Fine. Okay, how you will check the load is applied, both load are applied? Click on this frame element and do right click. Fine. From this window you can just click on the loads. From this load you can see load pattern dead, and it is applied. Start force is 2.2 at 0 pole location, then an end point it is 2.824 feet. Fine. Similarly, uh, load pattern, that is the live load, and it is applied at 1.6 and 1.6. Fine. So both dead and live loads are applied. Once you applied the loads, now we are in position to run analysis. How you will run analysis? You can run analysis, either click on analyze menu, then run analysis. And you can also perform run analysis by pressing F5. It is a shortcut for run analysis. Right? Click on the run analysis. So now from here, you want to set load cases to run. Right? So in this case, I want to run all the load cases. So just click on the run now. Okay, before it give you the result, you will save your file. Now the analysis is completed. So after completion of analysis, we are entered into phase 3. In this phase, you will see different results. How? Okay, the result are accessed from the display menu. It is a display menu. From this menu, you just go click on the display, then you can come to the show forces and stresses. Right? If you want to see forces or stresses at joint, so you just click on the joints. So this window will appear, and you want to check result for the combination of 1.2 dead load plus 1.6 live load, or you also check your result for dead and live separately. So we want to check the result for 1.2 dead load plus 1.6 live load. So I will select it from here and just click on this. So it will give you the reactions. Fine. Now if you want to check the shear force and the bending moment, so again click on the display, and from the display option show forces and stresses, then click on the frame and cables, frames oblique cables. Right? From here you can see different shear forces and bending moment diagram. Fine. If you want to see the bending moment, so click on the M33, and from here if you want to see values on the diagram, so click on the show values on diagram and click on OK. So from here you can check the bending moment diagram along with the values. Okay, if you want to check the shear force, again you can click on the display cables. From here you can check shear to click. So this is the shear force diagram. Right? You can also access these different results from this menu. From here, right, you can click on the joint, you can see the reactions, and from frame and cable you can check the other results. Okay, Thank you. Okay, this is all about example number 1. This is example number 2. Now I will solve this example in SAP2000. It is a simply supported beam subjected to different kind of loads, including the uniformly varying load at two different locations, and there is a point load as well. So the concrete properties is given over here, and the cross section is actually 12 by 14, and the load combination is 1.2 dead load plus 1.6 live load. Now I will solve this example in SAP 2000. Okay, the very first step is to create a new model. Just click on the file, then click on the new model. In this window, you will first of all set your units as per the requirement, and then click on the grid only. Now we will check how many grid line we required in the different direction and what will be the spacing of these grid lines. Okay, as I told you earlier that the grid lines are created where supports are required, where the loads is varying, okay, where the cross section is varying. But here there is a two supports and loads is also varying at different location. So now how many grid line we required in this X direction? Fine. So this is grid line 1 we required, and this is grid line second one, and this is third one, because the load is varying in this between these two grid lines. Also we required grid line this at that location, and we required grid line at this location as well, because the load is varying in this in these between these 2 points. We can also create grid line at this particular point and at this particular point, but in SAP 2000 you have there is option you can apply trapezoidal load which is varying at 4 different locations. So that's why I'm only defining 2 grid line for this particular load. Okay, we will define a grid line for this point load as well, and for this support condition. Okay, so how many grid line in the X direction? 1, 2, 3, 4, 5, 6, and 7. Fine. So we will define 7 grid line in X direction. Okay, what will be the spacing between these grid lines? Fine. Initially, we cannot add different spacing at a time, but later on we can edit the spacing as per the requirement. Now I will define 7 grid line in the X direction. So there is no grid line required in the Y and Z direction. So I will keep 5 feet spacing randomly, and later on we can edit the spacing between these grid line. Click on OK. Okay, the grid line will not be visible in this particular plane, so you will switch to XZ plane where you can see the grid points. Okay, now we will edit grid spacing. So how you will edit grid spacing? Just right click on the grid line, then click on the grid edit grid data, and then click on the modify and show system. Okay, from here you will change your grid spacing. Fine. So the display grid as it is actually shown in the form of ordinates. So keep in mind this thing, ordinate is measure from the origin, and the origin it location A. Fine. And the rest of the distances are measure from this A point, and it is cumulative. You can see it is 0, then 5, 10, 15, 20, 25, and 30. These are the cumulative value. Now we will edit, change these spacing according to the requirement. Now come toward the example number 2. From here you can see this grid line at location 0, and the second line is at location 2. Third grid line is at location 6 plus 2, 8. And fourth grid line at location 10. Fine. And fifth grid line at location 20. Sixth grid line at location 25. And the last one at location 30. Now we will edit these spacing according to this. Okay, this is at 0, the second grid line at location 2, third grid line at location 8, fourth one is at location 10, fifth one placed at location 20, and 6 and 7 at 25 and 30. Click on OK. Then OK. Now the grids spacing are added according to the requirement. Now we will define different properties. Click on the define. Then first of all you will define your material property. Click on the materials. Click on the new materials. Then change the name from here concrete 4 KSI. Right? From material type, change material type from steel to concrete and change your unit. Okay. Now enter the different properties from here. It is actually 36,000 and it is 0.2 Poisson ratio is 0.2 and this is 4 KSI. Click on OK. The concrete 4 KSI is defined. Now define frame section. Okay, the section property for this example 2 is 12 cross 14. Right? And define frame section. Click on the frame define, then section property, then frame section. Add new property. From frame section property type, change steel to concrete, and in our case the cross section is rectangular one, so click on the rectangular. Then change the name of this section, it is 12 cross 14. Okay, and change the material type, which is concrete 4 KSI. Then enter the dimensions. The depth is 14 by 12 because the unit in feet, and width is 12 by 12. Right? And concrete reinforcement, change design type from column to beam. Click on OK. OK. Now this frame section is defined. Now define load pattern. Okay. In this example number 2, all the loads are dead load, so there is no need to define any other load pattern. So the dead load is already defined. Okay, in the load cases, dead load case is already there. If you want to add another load case, you can add. How? Click on the add new load case. So from here you can give name to case 1, and it is static, and the analysis type is also linear. So from here you can add dead load twice. Fine. Okay, then define the load combinations. Click on the define, then load combination, then add new combo. Okay, change the name of this combination 1.2. For example, it is 1.2 dead load only. Right? So add 1.2 dead load because there is no other load. So only dead load, so it is 1.2 dead load. Click on OK. OK. Fine. Now you are in position to draw your element. Click on this draw tool and change the section property, which is already one property there. So it is by default selected beam 12 cross 14. So draw this element point to point. Okay. Now assign joints. At this location, it is hinge supported. Click this particular point, then go to the assign, then joints, then click on restrain, then keep it hinge support, assign, joints, restrain, and it is roller support. Now we will apply different loads. From figure, this is the load and it is applied between grade 2 and 3. So first of all, we apply this load. At location 1, there is 2 kip per foot load is applied, and at location 2, it is 1 kip per foot load applied. So I will apply this load in this particular section. So first of all, you will select the section where you want to apply the load. So this is the section. I select this one and then go to the assign. Then click on the frame loads, then distribute it. Right? And it is a dead load. So it is change from here. It is already dead load. Then it is force in the gravity direction. Now from this trapezoidal load, you will apply that particular uniformly varying load. Okay? While putting the distance and the loads accordingly. So in this example, this particular load can be applied by entering load at 2 locations, at this location and at this location, right? I will consider this location 0, then it is the other location, right? So how you will apply this load? So at distance 0, and what is this distance 0? This distance 0 is represented by this point, which is point B. This is the location of this 0 distance. At this 0 location, the load is how much? It is 2 kip per foot. Now, what about the other point? Because we can draw this load by 2 points only, because the load is varying at 2 location, 2 points. And the second point is, which is the C location, this location. Fine. So what is this second location distance? Keep in mind, from here, this is the relative distance from end I. Means if this option is checked, it means that the distance will be measured from this location and also in the fraction form, means an out of 1. So what is this location? The total distance is 6 feet. This frame is of 6 feet distance. So how you will determine this fraction? So it is actually 6 by 6. Fine. And at one location, actually this is a one location, and the load at this one location is 1. Rest, there is no need to use this 3 point number 3 and 4. So only this 2 point can draw this particular load. Click on OK. So the load is applied. Right? Now come toward this load. For this particular load, you required 4 points. Right? So this is started from 4th grid point to the 5th one. So first of all, I will select this particular frame element. Right? This is actually the element between grid point D and E. So click on this one and then go to the assign, then frame loads, distributed load. Now we will put distance and load to draw a particular load given in the example. If you can see from here, we required 4 points to draw this load. What are the points? This is 1, this is second, this is third, and this is fourth. Why? Because the load is varying at 4 location. At this particular location, and we call it, it is a 0 location. At 0 location, the load is 1. Sorry, at the 0 location, the load is 0. And at this location, in this particular location, the load is 1. And at this location, the load is again become 2. And at the final location, the load is 0. So what will be the distance now? And what will be the load? So we will enter that in the trapezoidal load option. Okay, at distance 0, the load is also 0. At distance, and how you will determine this distance 2? Okay, this distance 2 is determined. Actually, the formula for that is distance from the origin, and for origin for that is this one, right? Divide by total distance of the member. Fine. So the distance is the from the origin to this particular point, and total distance is the total distance of this member. So now if you want to calculate this distance, so what is the distance from the origin to this point? It is actually 2. And what is the total distance? The total distance of this member is 10. So this is how you will determine the distance to the point 2. Fine. Now come here at point 2, the distance is 2 divided by 10, right? And at this location, the load is 1 kip per foot. And now how to determine the third distance? It's very simple. Again, the distance from origin to this third point is 8. 8 divided by 10, right, to the third point. Okay, distance to the third point will be 8 divided by 10. So what is load at third location? It is 2 kip per foot. And the final point is the distance from the origin to this point divided by the total distance, and both are same. So it become 1, and load at this particular location is 0. So now you have defined the load, which is a trapezoidal load, and click on OK. So the load that you want to apply is actually applied on the particular section. Okay, now we are in position to apply the last load, that is the point load. Okay, that is 30 kip. Now select the point where you want to apply the point load, then go to the assign, then joint load, then forces. Okay, when you click on the forces, so this window will appear. Again, there is a load pattern name. You will change load pattern accordingly, and then you can change your unit as per your requirement. Okay, loads direction. These are the load direction, right? As per the SAP, the location, the load direction in our case is Z direction, but negative to Z direction, because in the SAP, upward direction is positive and downward is negative. For downward load, you will put negative sign with the load, that is 30 kip, and the Z direction, right? 30 kip load is applied. When you apply a point load, so all other uniformly varying load or uniformly distributed load will disappear. So how you can make it visible again? So just go to the display option, then click on the show load assignments. At joint location, the loads are already visible, so you have to make it visible at frame location only. Click on this point and click on OK. So all loads will be appeared at a time, right? Now we are in position to run analysis. So click on this run analysis, or you can also press F5 to run analysis. click on the run analysis. Now click on the run analysis. Run now. Save your file with example 2. Analysis is completed. Now you are in position to see different results. From this option, you can check the reactions at joints. So click on this. So from here you can see reaction because of dead load only. You can also see because of case 1 and also from because of 1.2 dead load. Click on the 1.2 dead load, click on OK. So it will display the joint reaction. If you want to see the shear force and bending moment, you can again access it from here. Click on this icon, then frame and cables. Okay, from here you can check M33, and if you want to see show values on the diagram as well, so click on this, check this option and click on OK. Okay, this will display the shear bending moment diagram. Now for the shear force diagram, again you will click on this frame and cables. So from here you can check shear 2 OK. So this will display a shear force diagram. This is all about example 2. This is example number 3. It is also a continuous beam which is subjected to differing loading, including the uniformly varying load and the point load. Along with these load, it is also subjected to bending moment as well, right? And this beam is having two different cross section. The cross section 1 is 14 cross 18 inches, and the cross section 2 is 14 cross 14 inches, right? And the other properties are given also, and I consider that all the loads applied on this beam is dead load, right? Now I will open the SAP2000 and will solve this example. Again, first of all, you will go to create a new model, then go to the file, then click on the new model, and from here you will set your unit according to your requirement. So all the units here is kilonewton in a kilonewton and meter. So set unit to kilonewton and meter, then click on the grid only. Okay. In here you will decide number of grid lines in X and Y and Z direction. So the number of grid line in X direction will be decided from the figure. Let's see the figure. Okay, how many grid lines we required in X direction? So as I told you that you will provide the grid line in the direct in the point where there is change of any cross section, there is where you want to apply load and where the load is varying, right? Or where you want to apply as a certain support. Fine. In this case, we required a grid line at this location because there is support, and we also required grid line at this location because there is change of cross section, and there is also load applied, uniformly varying load, and a pointed load, right? We required a grid line at this location because there is a support condition as well as a bending moment is applied. Again, we required grid line at this location, and finally at this location. How many grid line we have? 1, 2, 3, 4, and 5. So we required 5 grid line in X direction, right? So again, go to the new model, click on the grid only, and set here 5, right? And there is no need of grid line in Y direction and Z direction. Okay, I will just put 5 meter spacing. Later on we can edit this spacing. Fine. Again change the plane to XZ, where you can see the different grid points. And now we will edit grid line according to the structure. Okay, this first grid line at location 0, and the second grid line at location 6, third grid line at location 10, fourth grid line at location 15, and the final one is at location 20. Right? First one is 6, 0, then 6, 10, 15, and 20. So the total distance is 20 meter. Right? So we will edit grid line accordingly. From here, first grid line is 0, the second one is at 6, third one is 10 location, fourth at 15, and the final at location 20. Click on OK. Now grid lines are edited accordingly. Now next step is to define the material property. Click on the define, then materials, add new materials. From here change the material name to concrete 4KSI. Okay, now change the unit according to the requirement. Keep inches, then change your materials type from steel to the concrete. So this is 36,000 and it is 0.2, and compressive strength is 4 KSI. Okay, click on OK. Now I will define the frame section properties. Okay, actually the frame section property in inches, so you will change units from here from kilonewton meter to inches. Right? Now go to the define, then section properties and frame section. Keep in mind we have two different frame sections. So first of all we will define first frame section made of concrete, and it is a rectangular one, and we give name it to beam 14 cross 18. Right? And the depth, sorry, select material from here, and it is made of concrete 4 KSI, and depth of this is 18 and width is 14. Fine. Change the concrete reinforcement from column design to the beam design and click OK. So this is defined. Now you can also add copy of this beam. So add copy of this property. Just change name from to 14 cross 14. Then depth is also 14 and width is 14. Click on OK. So these two beam sections are defined. Click on OK. Now define load pattern. As I told you earlier that the load is subjected to dead load only. So the load pattern is by default defined here, which is dead load. So there is no need to define again. So click on OK, then define load cases. So I want to run dead load case only. So there is no need to define load case. Then go to the load combination. So load combination is 1.2 dead load. So define that 1.2 dead load. So add 1.2 dead load. Click on OK. So load combination is defined. Now we are in position to draw this beam. So click on the draw frame element, and first member is actually made of from this location to the first location, from location 1 to 2. It is made of section 12 cross 18. So from this location to this, the section is 14 to 18. So we will select from this beam, instead of 14 to 14, it will be 14 to 18. So this section is from this location to the B location, right? Now after drawing this area, this frame section, change the section property to 14 to 14 and draw rest of the, right? This portion is 14 cross 18, and the other location, the other frame section properties is 14 cross 14, right? Now we are in position to assign joints. At this location, the joint is fixed support. So select this location and then go to the assign, then joints, then restraints, and click on the fixed support. Click on OK. So fixed support is assigned. Then a roller support is at this location. So this is the third location. So actually this is at this third location, and also the roller support at the end. So roller support is also here in the location E. So assign roller support to these two joints. Go to the assign, then joints, then restraints, and click on the roller support. Right? The supports condition are completed. Now we are in position to apply different loads. First of all, we will apply this uniformly varying load. We call it triangular load. And how we will apply this? We will first of all select the frame section. Okay, we will select this particular frame section, then go to the assign, then frame loads. In the frame loads, we will go to the distributed load, right? And the load pattern name is dead load. We are just applying the dead load here. So from the trapezoidal load, we can apply this particular load. At distance 0, the load is how much? It is 30 kilonewton per meter. Keep in mind, from here you will change your unit according to kilonewton meter, and you will apply at 0, the load is 30 kilonewton. Now at location, last location, which is actually one location, and the load at this location is 0, right? Click OK. So this load is applied, right? We can change the unit to kilonewton so that it will show in kilonewton meter, right? Okay, next load is applied at this edge again, which is 200 kilonewton. Now we will apply load at this particular joint, which is 30 kilonewton, sorry, 200 kilonewton. Select this joint, then go to the assign, then joint loads, then forces. From here, you will apply load at global Z direction, but in opposite to that one, you will put negative sign 200. Okay, the load 200 is applied over here. Now next load is at, it is actually the bending moment. It is applied at this location, which is the third location, which is 90 kilonewton meter. So how you will apply this bending moment? So for application of this bending moment, first of all, you will check, you will analyze the direction of this bending moment by using right hand rule. By right hand rule, if you encircle, if you rotate your fingers in the direction of this arrow, right? If you rotate your fingers in the direction of this bending moment, the thumb will give you the direction of bending moment, right? Okay, if we apply right hand rule to this particular bending moment, So the thumb is toward the screen, and toward the screen direction is actually Z direction. Sorry, actually Y direction in the case of SAP, right? So here the direction of bending moment is toward Y, and it is toward positive Y, right? So we will now apply this bending moment 90 kilonewton meter in the Y direction at this particular location. Okay, now I will apply this 90 kilonewton meter bending moment at this location, which is location C. So what you will do, you will just select this location, then go to the assign, then joint load, then forces. Okay, from here you will enter bending moment about global Y direction but positive value. Keep in mind this is already here, so you will make it 0. Otherwise the same uh, along with the bending moment, the 200 kilonewton point load will also apply at this location. So that's why make this force 0, right? And just keep 90 kilonewton meter bending moment at this location. Click on OK. So you cannot see the bending moment because this is XZ plane, and the XZ plane there is no bending moment, so the bending moment is applied in the Y direction. So you can see this in XY, right? Or you can also see this in the Z, in the 3D. Fine. Okay. Now again there is another point load located applied at this location. We will apply now 150 kilonewton load at this location. First of all, you will select this location, then go to the assign, then joint load, then forces. Okay, at here you will also make this bending moment 0 and just apply a 150 kilonewton point load in the opposite direction to Z. So you will keep negative sign. Click on OK. So 150 kilonewton load is applied. In order to visible all different loads applied on this beam, you will just go to the display, then show load assignments. Loads at joint is already shown, so click on the frame cable only, then OK. So all the loads are visible. If you convert your view into 3D, so you can see there is a 90 kilonewton meter bending moment, and there is a 200 kilonewton point load at this location, and there is a uniformly varying load as well, and 150 kilonewton point at this location, right? Now we are in position to run analysis. Now click on the run analysis and run now. Save this file with example 3. Now analysis is completed. Now we are positioned to check different results. If you want to check the joints reaction, so click on this and then joints, and for combination 1.2 dead load, click on OK. So these are the reactions. Fine. Now if you want to check the bending moment and shear force diagram, then first of all for M33, if you want to see values on the diagram, to click on this show values on the diagram, click OK. So this is actually the bending moment diagram, right? If you want to see the shear force diagram, so click again on this one and click on the shear 22. So this will give you the shear force diagram. If you want to see all the different responses at a time, so click on the particular frame, so right click on the particular element. So this will give you the complete result. That will give you directly the distance load, the load applied per unit meter, and then the shear force, the bending moment, and deflection as well, right? Okay, this is all about example number 3. And with this example, the tutorial number 1 is concluded. Thank you so much.